Ours are just crispy burnt.
Yeah, yeah. Well, it's gonna be a long road. It seems like every time I go out there, it looks worse.
Oh yeah, I agree. It looked bad, and then it's looking worse and worse and worse. And then, hopefully some green will start showing up, but I don't know.
I was really surprised how quickly the Anaquas came out, though. They lost all their leaves. They got burned, and I don't think I've ever seen them burn. As I lived here my whole life. I can't remember when the Anaquas ever burned, but they did. But now they're coming back like gangbusters. So that's good.
On another note, the Brazilian pepper is gone.
That's good.
Most of the stuff around here is just dead.
Yeah.
I'm hoping it doesn't come back up.
On the Resaca where we live, it's still brown, and that's what Robert's hoping.
Yes.
Is that because he'll cut ours back, what's in our yard, and keep it cut back, but then right across the fence in the refuge, we can't cut it, and so we're hoping that but even if it knocks it way back, it's still brown. So
yeah. The native stuff I think is gonna rebound. That plant I love so much, that Mexican bastardia, the one that has that odor. Man, it got toasted. I sure hope that little buddy comes back, because I only have one. Anyway.
Well, we have a little crop at Ramsey, so if it comes back, I mean, we went the next day after the freeze and walked around just to see what was happening at Ramsey. So I'm so glad we made the video before the freeze, because I'd be walking around talking about these brown plants if it were now. But we had some beautiful tulipans that we had planted and were doing just fabulously. And they were like 3 feet tall, and they just, they may come back, but they're picked them. So, it's one of those things that the natives obviously have a better chance. But one thing I heard was that unfortunately they're very good at adjusting to the temperature, but this time the temperature plummeted so drastically that they didn't have the normal chance to recalculate. So
that's what happened to the fish too. I'm sure they didn't have any real time to acclimate.
Absolutely.
We have a fishing cabin up in the land cut north of Port Mansfield. One of my partners sent some pictures of the kill up there, and it's got to be in the millions. Wow. It's so sad. Is Reisinger on here? We ought to ask him about that.
I'm on here, Pete, and I talked to Willie Cupid with Parks and Wildlife, and he said it's approaching 4 million, and we had more in 83 and 89. That's their latest. It could go up from there.
Oh, man.
But there are a lot of dead fish.
That's such a shame. Well, I tell you what, though, the Laguna Mama is really resilient. So I was amazed after 83 and 89 how fast, they came back. But, man, it needs to be catch and release for a while here,
Yeah, it does. They, all of my cedar elms have almost completely leafed out. It's amazing. They all lost their leaves, but now I have shade.
Well, they always lose their leaves most of their leaves in the winter. So I was surprised. We have one that was knocked like halfway over from Hannah, and so it's like the root ball is sticking halfway up out of the ground, and it's like tipped over into the Resaca. And Robert, of course, being the naysayer he is, thought it was dead. And it's completely leafed out. So
Wow.
we've also noticed that some of the wildflowers that we had planted, we had to have some work done on our sprinkler system. So while we had the whole yard dug up, we planted some wildflowers from the native plant, native seed place, and several of those wildflowers are coming up. We have a Versace daisy out in the middle of our yard. So
Wow.
it's like some things like this.
Yeah.
So, but it's an interesting study. I really don't want to do this study. I'd rather have your beautiful backyard, Pete, and
Me too.
I'd rather have nothing to study and be able to take people out and show them how great Ramsey is. But hey, you have to work with what you got.
Yeah, it's really, really sad.
And really sad for all the citrus growers and the crops and the...
Yeah, I went up to the ranch in Steve Shepard's ranch in northwestern Stark County Saturday. We went up there just to check it out, spend the night. It's a beating up there with the extreme drought they've got up there, plus the freeze. And some poor guy right along the Hidalgo County, Stark County line had planted a big baby citrus orchard, okay, which is a lot of investment. And it was really sad to see that. Poor buddy. I don't know if any of those are going to survive. It's really sad.
The black mangroves got hammered too.
Oh, I was going to ask you about that.
Yeah. They'll come back. They get knocked down, but they come back from their roots, which is a good thing. But at one time, someone said there were reports of black mangroves that were 30 feet tall here in the valley. I don't remember when.
Well, look at the ones at the convention center. I mean, it's unbelievable how big those things got. I think it has something to do with the effluent going out of the sewer plant there, but man, those things are huge. And Richard and I drove the Bayside Drive a few days after the freeze on the refuge, and man, it's ugly. You can see there's going to be tremendous damage.
Yeah, I think you said there were 15 dead sea turtles along there too, right?
We didn't see any, but they probably had already cleaned them.
I think you went back and saw some or whatever.
Yeah. Oh boy. Well, does the program start at 7? Is that the plan, or do we?
Yes. Yes. The meeting starts at 7. We have a couple announcements, and then Dr. Gabler comes on right after that.
Cool. Okay. Great.
Barbara, are you going to do Turtle Patrol? I saw you on the training on Saturday.
Yes. Yes, we did the training, and the coordinator for the volunteers has us on their list. We're going to walk.
It was long, wasn't it?
Well, because we only are going to walk, we only had to watch till 11, whatever, when they did that break. But you had to do the whole day, right?
Till 3.
Yeah.
And then we have another training with sea turtle. There's another training.
Do we?
The only one I don't have to do is the hands-on ATV, since I've been doing it so long.
For like 50 years, right?
This is my 17th year.
Wow.
Yeah.
That's amazing.
And I'm just as excited this year as I was the first year.
Hey, there's a lot to be said for that.
It's like starting first grade. You get the first day jitters. Mexico's already got their first nest.
Oh, really?
Yeah, they got it on Saturday.
Wow. We need to get you. We went to that presentation at Port Isabel at the.
Oh, when I
museum,
did the patroller thing?
where you had your whole get up on and
Yeah.
and all your stuff. And I've seen. Well, I was in Dallas when Robert was doing that, and he would send me pictures of, all his paraphernalia. But to see you in person and that, and have you talk about all that stuff is really good.
Well, I talked to Steve Fowler right after I saw that Mexico had gotten their first nest. His training got canceled. It was one of the ones during the week that got canceled, and I think he's doing it tomorrow. I'm not sure. But
Yeah, they told me that they added a couple more because of the whole, they had to cancel some of the ones that they had.
But they had so many people sign up.
Linda,
Yes.
did he say how Joyce is doing?
Yes, Joyce is doing good. They're moving their RV to Isla Blanca Park on the 1st of April
Wow, that's great news. Good.
because they don't want to be messing around with the lift bridge, with the swing bridge. They don't want to get delayed with that. Especially if Steve goes back on patrol. So, or if Joyce has a medical emergency or whatever, they want to have, quicker access.
Hey, Linda,
Yes.
sorry to interrupt, but I tried to sign up for the beach patrolling, and I sent an email to PAIS.
Uh-huh.
But they had a link on there, and when I pressed the link, it was just a message. So I said to please sign Dan and I up for the patrolling, and I haven't gotten a link back I haven't heard back from them. So
Okay.
did you have to fill out a form?
No, I think I had to answer some questions.
There wasn't
But
anything like that on what I got. It was just a blank email. So I wrote, we would like to sign up for it, but I haven't heard from them.
okay, what I did was my email, or I tried to, get through them on the link also. So I just ended up calling them, and a lady picked up the phone on the second ring, and I called at like 8 o'clock in the morning, and she said they're open at 7, and that's how I got signed up.
And then they emailed you the link, right?
Yes.
Okay.
But the thing about it is, they use Microsoft Teams, and the instructions that they gave me, I went through the night before. I took pictures of the steps with my phone, and I even wrote it all down, and it didn't work. So I had to end up. It's a good thing I got on early. Started trying to get on there early. Because I had to end up downloading Microsoft Teams to get on. And I got on 3 minutes before the thing started.
Okay.
Did you have trouble, Barbara?
No, I just clicked. All they did was send me a link, like boom, like no words, nothing, and a link, and then I did what it said, and we got on.
Wow, that's weird. Well, anyway, Chris, I'd call them.
Okay, I'll do that tomorrow.
And like I said, they're open at 7 o'clock in the morning. I called when Mariana first gave us that info, that email. I called, or I started trying to get on like in the first 15 minutes
Okay.
of that day, that next day. And like I said, I couldn't get online, and so I called.
Okay.
And she answered the phone right away.
Okay, thanks.
I saw Chris get on and I saw him like this.
And he said, I can't share yet. I share yet.
Are we on mute?
No, I'm trying to mute.
Good evening, folks. See some familiar faces and more familiar names. While they're working that out, I think this is the 5th time I've been able to have the pleasure to talk to a Texas Master Naturalist group. So I'm doing something right. You guys keep inviting me back, so I'm excited to be here. One of these days, I'm actually gonna join myself. Maybe when I don't have young kids, or at least they're old enough to bring them along.
That would be great. We're glad you're here, Chris.
Happy to be here. Very happy to be here.
And Diane, what are you showing us?
Teresa was asking about what I use for butterfly feeders, and this is it. It's a sponge. What's up? A sponge. And I know we just went to the plastic symposium, but it's a plastic pan strut sponge.
They use the same thing. Oh, sorry. Go ahead, Diane.
They insert the proboscis down in here, and the water soaks up into the sponge, and then the butterflies can put their proboscis down into this plastic piece, and they don't get wet. So that's what my darling Chip Taylor at KU said to use to feed. That's what they feed their monarchs with in captivity.
They use the same thing in at the Cockerell Butterfly Center in Houston, associated with the Natural Science Museum, and I always think it's the big pyramid they have there. And it's always funny to pay my $20 cover and then see them drinking from dish sponges. But they work really well.
Yes, they do. That way the butterfly's feet and wings don't get wet or sticky.
Yep.
So
Okay, that's
my butterfly feeder.
Thank you, Diana.
All right, everyone. Let's. It's a little bit after 7 o'clock. Let's go ahead and get started. And let me just get confirmation that you're able to see my screen.
We see it
Yes.
well.
Yes.
Yes.
All right, perfect. Welcome everyone to our March chapter meeting. I think you'll recognize my theme on my slides pretty quickly. Thank you all for coming. We have a few announcements that I want to go through before we have our speaker for tonight, Dr. Christopher Gabler. One of the things that I want to make sure everybody knows, well, first of all, if you've already paid your dues, thank you very much. We definitely appreciate that. If you haven't, please do so. You can go to our website. You will find the link to pay the dues right at the front page. You can pay either by PayPal or mail a check, and you'll find that address out there for us as well. If you're a Winter Texan and you haven't already let me know, please email me at riograndevalleychapter.tmn@gmail.com. We are part of the unique area of Texas that we do have Winter Texans, and we're making a very strong effort to try to stay in contact after you travel and go up to your home away from home. So please let us know. We want to make sure that we stay in contact with you wherever you are. So we definitely appreciate that. I do want to share some recognition of milestones that we've had. We have had 2 members. Pamela Bradley has hit 100 hours, and Diane Hall has hit 250 hours. So congratulations to the both of them. As you can tell by their garb, we will always remember the cold freeze that we went through. So some of you that don't know Diane and don't know Pamela, you still don't know them based on this picture, but look for their winter weather gear and you'll recognize them. But congratulations to the both of them. We also have a newly certified TMN, Tanya Tallard. For some of us, we got to spend some time with her this past week at the Pollution Symposium. Congratulations, Tanya. One of the really neat things that she's trying to do for sort of to get us ready for a big cleanup that she is planning for later in the summer is she's trying to get everyone to make a pledge to pick up some trash. And I think this was a very noble attempt for us to do that. She's been doing this for quite some time, so definitely thank Tanya next time you see her for her efforts to try to keep our beaches clean, and also congratulate her for achieving her certification with us. All right, so tonight's speaker, Dr. Gabler, Barbara P.
Okay. We're very pleased to have Dr. Gabler, pleased and lucky to have Dr. Gabler tonight. He leads the Plant Ecology and Sustainability Lab at UTRGV. Their work focuses on global change and finding practical ways to reverse the current rapid decline in biodiversity and ecosystem function. He received his PhD from Rice University in 2012 and held postdoc positions at the University of Houston and the U.S. Geological Survey National Wetlands Research Center. He joined the faculty at UTRGV in 2016. He is currently an assistant professor and the program coordinator for their Bachelor of Science program in Sustainable Agriculture and Food Systems. His research focuses mainly on ecological restoration, climate change, invasive species, and sustainable agriculture, and he works most frequently in coastal ecosystems, wetlands, and forests. So he's all over the place, and we're glad to have him tonight. So thank you, Dr. Gabler, for being here.
Thank you, Barbara. That was a very kind introduction, and I am all over the place. I like to say that my greatest strength and weakness is how spread out my work is. So sometimes I'm definitely the jack of all trades kind of ecologist, but in a very synthetic school of thought that actually tends to pan out and work well. So let me go ahead and share my screen here, and I'll pull up my talk. And everyone should be seeing this. Should be maximized. Everyone's seeing the PowerPoint slide with some really fabulous zonation from not far from Adolphe Thomé launch point, heading into the Laguna Madre here. So I'm going to talk to you guys about one of the aspects of climate change and its implications that often doesn't get the same kind of attention in these coastal systems as does sea level rise. And so sea level rise is obviously a really big factor in these coastal wetlands, but I'm going to talk to you about how just the changes in climate, just temperature and precipitation, and especially precipitation, is going to impact these systems and the people that rely on them. So I want to start by reminding you guys, and this is a group that I don't need to give too much introduction to, that there are lots of different kinds of wetlands, right? Freshwater, saltwater, and even different kinds of coastal wetlands. And what we're going to focus on here are those wetlands that are influenced by tides, right? So those kinds of coastal wetlands. And one of the cool things about these is that wherever you find these in the world, the plants that live in this intertidal zone, they all focus and face the same kinds of challenges, right? So they have flooding and they have salt stress, as well as the same kind of opportunities. They have these regular inputs of organic matter, for example. And so we're going to focus also in these intertidal wetlands on functional groups more than particular species. And there's sort of two important reasons for this that bear explaining at the start. The first is that these four functional groups you see right here are dominant in coastal wetlands here and around the world, right? So functional group patterns here in South Texas are relevant worldwide, okay? And the second big reason is that, you know, species do this too, but more than species, plant functional groups really drive ecosystem function. And so by extension of ecosystem function, also ecosystem services. And as you probably already know, these wetlands and their ecosystem services are very important both ecologically and economically. And so we'll talk more about ecosystem services in a handful of slides. But these are the big four. These are the main four plant functional groups that dominate wetlands across the world. So at the top left, you've got a picture of graminoid dominance. So these are dominated by graminoids and grass-like plants. So things like grasses, sedges, and rushes. Top right are the mangroves. These are woody trees and shrubs that are particularly well adapted and specialize in these intertidal zones. The bottom left are the succulent plants, right? So these have fleshy stems or leaves, and they are able to, one of the ways they deal with salt stress is by storing water, like a cactus. And you indeed find some opuntia out in some of these areas. And then at the bottom right, it's not really a plant functional group, but it's worth considering because these unvegetated zones are important. These mudflats are important habitats, and they also range from bare mudflats that are nevertheless important to things that are very thick and have quite productive photosynthetic algal mats, like the ones you see here these are actually from Baffin Bay. And last thing on these functional groups is that they're what we call foundational, okay? So these are foundational groups and foundational plants because they span large spatial areas. You'll find acres and acres of these things. They provide the physical structure that defines a habitat, right? A forest is a forest because of the trees, and grassland is grassland because of the grasses. And they're the foundation of all the local food webs, right? These are the main primary producers. They do the bulk, the heavy lifting in terms of photosynthesis. They're the foundation of food webs. So these are very important. All right, so these are four groups that are already probably very familiar to you, and here are four local examples. So these are all photos taken in Laguna Madre. They're all South Texas, Rio Grande Valley area. And that's one of the cool things about our part of the world is that we actually have all four of these functional groups. And that's not true of most places. So the south sort of Texas coastal bend downward and into northern Mexico, we have some really cool, functionally diverse wetlands. So looking a bit closer at these, so here is Spartina alterniflora. This is not far from Port Isabel. This is probably one of the more rare of these functional groups. We don't have that much Spartina. We don't have that much grass. And that's because of how salty it is around here and how dry it is. And so this area, you can see that there are oysters interspersed throughout all this, and that's not uncommon. But the reason we see not very much Spartina is that most of the places where it can grow, it's in direct competition with the mangroves locally, and those tend to outcompete them. And so you'll often see really narrow fringes of Spartina because there's this one bit of elevation, relative to sea level, where they still can win against Spartina. And this happens to be one area where that little bit of elevation was pretty wide. All right, so here's some mangroves. Now the mangroves here are very different than the mangroves in other parts of Texas and way different than the other parts of the United States, namely in Florida. I won't get into Hawaii, but partly because I've never been there. But the mangrove, they're a lot bigger here than when we get further north and get into Corpus Christi and places like Mission Aransas. We have some pretty old, pretty tall black mangroves, but it's only black mangroves. We have the odd red mangrove that people have kind of put here, but these are the most frost tolerant, and they don't get too big, and that's partly because we get the occasional frost, and also just because it's relatively dry as far as wetlands go, and very salty, which is unlike Florida, where you'll have mangroves that are 60, 70 feet tall, big, tall, close canopy forests. Here's a patch of succulents. This is mostly saltwort, mostly Batis maritima. There's some Baricchia in there and some salicornia in there. And you can see that the darker green tall shrubs, those are black mangroves that like to stick up and grow around here. And in the back, you see more mangroves. That's them following a tidal channel. And then, of course, we also have the algae mats and the mudflats. And this is some pretty intense algae mats that are in Bahia Grande unit. This is me and two of my grad students setting up one of our climate change experiments. And this is what I'm going to talk about sort of the second half of this talk. This is pretty extreme example. Not all parts of the valley that have these algae mats are this thick. Here's an example where it's only a couple of centimeters, about 1 centimeter thick actually, as you can see from the soil core on the left. That was taken in the same place, but it's robust enough and sticks together well enough that it'll fold up and move around like this. It looks like carpet got, like astroturf got moved around from this part near, I think this is from near Boca Chica Beach. All right, but again, if you get enough nutrients and if the conditions are just right, these algae mats can get pretty incredibly thick and hardy. And this is photosynthetic. There's single-celled and filamentous algae in here. There's a whole bunch of different bacteria and fungi, and plenty of archaebacteria, I'm sure. So that's me on the left there holding up a manhole-sized chunk that I could throw like a frisbee if I wanted to, and they'll get to be 5-6 centimeters thick. Pretty cool stuff. All right, so now that we've touched on these functional groups, which are really the main characters in this story, let's just point out that the main question today, the big point today, is examining how these four functional groups, how these main actors respond to changes in rainfall. And knowing how these plant functional groups respond to rainfall is going to help us understand, and then by extension also predict, what's likely to happen to entire plant communities. And we can do this best at a large scale, and we can also predict what these changes are going to mean in response to any factors that are going to affect freshwater availability besides rainfall, right? So higher temperatures, that means more evaporation. So even if we have the same amount of rainfall, it's going to be warmer. That's going to mean less water available. We're also seeing increased runoff due to various types of land use change. We're seeing greater withdrawals of fresh water from watersheds for agricultural and industrial and municipal purposes, especially as our population in South Texas grows. We have more and more withdrawals. So water is already tight, and it's about to get a lot tighter. And so whatever happens with our rainfall, it's not likely to increase. If anything, it's more likely to decrease. And even if it stays the same, we're not going to have the same amount of fresh water available. So, of course, knowing this then helps us address a much broader and obviously big question of great societal importance, which is how is climate change going to impact coastal wetlands overall and the coastal communities that depend on these systems, as well as everybody else that depends on these systems. So now's a great time, and I'm sort of wrapping up my introduction here, to go ahead and answer another really important question that has to do with connecting these plant functional groups to coastal communities, to people, right? So that is, what are the human impacts, right? How do these changes in what is it that these changes in plant community actually mean for people, for regular people who may not be working in these fields? And this is often phrased as, why should I care, right? I'm sure you've fielded this question before. Well, the answer is because the types and the amounts of plants govern the types and the amounts of ecosystem services that land provides. And so this means that if we have changes in the plant community structure, this is also going to change the types and the amounts of the goods and services that we're getting from these coastal wetlands. And if you didn't already know, and I'm pretty sure this group did know it, coastal wetlands are the poster child for ecosystem services. I mean, they are exceptionally valuable. They provide storm protection, they provide erosion reduction, they help treat wastes coming through from our watersheds, they provide lots of wildlife habitat for a whole wide array of different groups of animals. Birds are probably the best known for this, not just this whooping crane, which lives in the coastal wetlands in Aransas, but all the birds that make this a great place for birding and fishing and ecotourism. They provide us with fishery support for both commercial and recreational fisheries. They help catch and clean water as it's moving through our watershed and towards the ocean. And I mentioned recreation and ecotourism. They're hugely important to that here in the valley, where birding and fishing are such big engines of our local economies. And they are fabulous, world-class ecosystems for providing carbon storage. Right, so this little figure on the bottom here shows how much carbon is getting stored by these different systems. And salt marshes and mangroves are much better than even tropical rainforests with immense huge trees and dense lush veg. And that's because they store so much carbon in the soil, so much below ground. And that makes sense because leaves and twigs and roots don't decompose very quickly when it's anoxic and salty. Those decomposers just don't go as fast, which means this carbon gets buried and stored and doesn't go back into the atmosphere, which is super important. All right. And I'll briefly point out, and we're not going to go into the details here, that we can estimate the values of these different ecosystem services in terms of dollars and cents. And when we do, we see that healthy coastal wetlands are worth an awful lot. The total down here, about almost $5 million per square kilometer per year, doing nothing. Just leave them alone and let them be wetlands and do what they do naturally. That's almost 10 times as much as we attribute tropical rainforests. And you know, Johnny on the street is going to tell you the tropical rainforests are valuable. And you can tell them, well, the coastal wetlands we have around here are 10 times as valuable in the same area. So hopefully you're convinced. I'm sure this group is. So let's now turn to the research story here that's going to be the main focus. And the story here really begins back in 2013. The current project I'm working on now sort of has its roots there. And in 2013, I was a postdoc working with the U.S. Geologic Survey. And we started this pretty ambitious experiment to build climate models, so like equations, predictable schemes, that would work for coastal wetlands. And it involved a really ambitious 2-year data collection marathon of field work. And it spanned the entire U.S. Gulf Coast, right? So the plan, and I'll touch on each of these individually, but here we see some photos taken from each of our estuary sites. So we had 10 estuary sites across the entire U.S. Gulf of Mexico coast. The plan was to do a very detailed survey of the entire plant communities across this broad range of temperatures and precipitations. Okay, so at the broadest scale, our sites had to include the relatively warm and dry estuaries of Texas, which get progressively warmer and drier as you go further south, as well as the relatively cool and wet areas. And hopefully you can, I don't know in WebEx, can you see my mouse in WebEx, or do I need to make it show my mouse pointer or something?
We can see it.
Okay, great. So these, Louisiana, Mississippi, Alabama, they're relatively cool and wet, as well as the sites in Florida, which are warm like Texas, but wet, like not quite as wet as Louisiana, but pretty wet. So we span this whole range, and we've been able to tease apart these two factors. And then within each of these different estuaries, within each of these areas, we positioned our different vegetation transects to capture estuary scale gradients, right? So big differences in salinity, big differences in tidal range, stuff that spans an entire region, right? And this allowed us to account for the variability in salinity from mouth of the estuary to further at the main freshwater input points. And then within these transects, at the narrowest scale, our sampling method was designed to capture local gradients, primarily elevation, which is hugely important for which plants you actually find at any given point in one of these wetlands, and to then characterize the transitions between these vegetation zones. And so the rationale behind this is pretty simple. It's well established, and you know this, everybody knows this, that climate governs where plants can grow. Right? So if you've ever looked at a USDA hardiness zone map, you know this. Certain plants can't survive in certain climates. Importantly, not only do these distributions map with climate. And a really great example of this is the figure on the top left. This is the classic Whittaker biome figure, which breaks all the main types of biomes in the world down along these gradients of precipitation and temperature. So at the top left, where you get the warmest, and it's warmer to the left, warm and wet, you have tropical rainforests, and where it's hot and dry, you're in subtropical deserts, and you don't really get anything over in cold and wet because water freezes, right? So in the tundra, it's dry because what water is there is frozen. And then everything in between, temperate deciduous forest kind of in the middle, and so on. And the same patterns hold true at more regional scales, local scales. So in Texas, we see a similar gradient. It roughly gets drier as you go further to the west, and of course we have a polar north-south temperature gradient. And this means it's sort of as you go from East Texas bottomland hardwood forests, you grade into tall grass prairies, you get into more scrubby land when you get into the hill country, and then finally you get into the Chisos Mountains and Chihuahuan Desert, and it's true desert. And importantly, these patterns with precipitation and temperature also vary along these important physical gradients, right? So you get colder as you go towards the poles, you get drier typically as you go farther away from water, and you get colder and drier as you go up in elevation. And so this creates these really distinctive global biome patterns. And the same is true for wetlands, right? Even within one particular kind of habitat, a wetland habitat, you get these different flavors of wetlands based on these gradients of temperature and precipitation. So in the warmest, wettest wetlands, you tend to have strongly mangrove-dominated ecosystems. Where it's relatively cold and dry, you're in a spartina alternative flora world. If it's hot and dry, you end up not really having much marsh either, and you can have completely unvegetated areas dominated by mudflats or algal mats. And then if you get sort of a little bit wetter, but it's still pretty hot, you'll have areas dominated by succulents. And so Texas, and kind of a bit of a spoiler, spans all this intersection, right? We're in the hot and dry part of the world, so we have this cool transition between all four of these major groups, which is the name of the game in this, and what we hope to figure out is happening with climate change. And so the Gulf of Mexico has these big gradients. Texas itself has these gradients, and it's a fabulous place to study how climate affects coastal wetlands. And so we carried out this big data collection effort over 2 years. We sampled in 10 estuaries. We covered a total of 70 different transects and over 1,000 individual study plots. And within each of these plots, we measured soil physicochemistry. We were looking at salinity and texture, density, and organic matter. We measured elevation very carefully with an RTK GPS unit because elevation is so important. This thing has sort of sub 2 centimeter accuracy. And of course, we looked at the plant community structure. So cover by species, and then how tall stuff was and how much biomass there was, which we used a non-destructive estimation method. All right, so on to the results. The first big finding is not so much a finding as it is a good demonstration of what people familiar with these areas already know. And that is that the functional group abundances and their distributions within wetlands vary broadly. They are highly variable across the estuaries of the northern Gulf of Mexico. And no, there probably aren't any big surprises here, right? So in sort of working our way plot-wise, from Lower Laguna Madre, we start off with areas that have a lot of unvegetated land in yellow. Oh, and let me point out the color coding here. This is going to be important for the rest of the talk. So graminoids are going to be in blue, mangroves are going to be in red, succulents are gray or black, and then unvegetated, including algal mats, are going to be in yellow. And think like sand to associate with yellow. But either way, just that's going to be the convention. All right, so a lot of unvegetated land in South Texas because it's so dry and salty. And where we have veg, a lot of it is succulent, a lot of it is mangroves, very little in the way of grasses and sedges and rushes. As you start to work your way up the Texas coast, you start to see less unvegetated land, more succulents, more grasses, and the mangroves start to peter out because it's starting to get colder, and the mangroves don't tolerate the cold. So by the time you get to Galveston Bay, you see a few token mangroves, but it's really not an important part of the system, and instead you have a whole lot of grasses. And still a good bit of succulents, just because that's sort of the nature of Texas. When you get into the coolest, wettest parts, Louisiana, Mississippi, Alabama, it's overwhelmingly grass dominant. And you'll occasionally find mangroves in particular places, like at the most southern extreme of Port Fourchon, the southernmost point in Louisiana. But you essentially don't see mangroves there because it's too cold. You do get some unvegetated bits from salt pans, and you'll occasionally see succulents, but it's a grass-dominated world. And then in Florida, Tampa is a mangrove world. It's warm and it's wet, and that's where mangroves are most abundant. You do see some grasses, occasionally see succulents, especially in the Everglades site, 10,000 Islands. That's some cool Everglade habitat there where you get some of these neat graminoids. But generally, Florida is your mangrove-dominated world. And so these vary broadly, but they vary as we would expect. So the next big finding was a lot more novel and a lot more interesting. And so what we did here is we basically just took the data from the prior image, so how much dominance, how much coverage there was of these different functional groups for each plot. So here, each point represents of a different shape, I should say. So all the down pointing triangles are one estuary, one of those 10 estuaries. Same thing with the other triangles, the diamonds, circles, and squares. Those are all an estuary. And so at a large scale, at an estuary scale, when we plot these functional groups, the abundance of these functional groups along these gradients of temperature here on the left and precipitation on the right, we see that first, there are some very strong relationships. But more importantly, is that these relationships are not linear. Right? You don't get a gradual increase or decrease in any of these things as you go up or down in climate parameters. What this means, what they're doing is almost all of these actually follow a sigmoidal curve, an S-shaped curve. And what this means is that there's a threshold value, there's a boundary value for either temperature or precipitation or both, where if you go, as you go past this boundary value, the group dominance shifts very rapidly and very profoundly. There's a turning point. And you can see it clear as a bell in the mangrove and graminoid figure here at the top left. At about -11, -10, and what this is the minimum temperature observed over a 30-year period. And I should point out that this is just one of several metrics of winter severity that produces a very similar plot. We could have looked at average winter temperature, we could have looked at number of freeze days, it doesn't matter. How severe winters are is this big factor for grass versus mangrove dominance. And so there's this turning point where you see, once you get warm enough to not kill mangroves with frost, grasses very quickly start to become far less dominant, and mangroves almost as quickly become far more dominant. You see a subtler pattern with precipitation. The overall pattern with precipitation is that you get an increase in total coverage as you get wetter, okay? And there is this S-shaped curve if you combine graminoids and mangroves, because they both like the relatively wet areas. The succulents, though, they kind of max out at about 1,000 millimeters of rainfall a year. They're never the overwhelming dominant feature in these systems. But very importantly, there's a negative S-shaped curve for unvegetated areas. When you start to get below 800 millimeters of rainfall a year, which is where we are in South Texas, the amount of unvegetated land goes up fast. And that's a big deal. So at the bottom, we don't need to pay too much attention to this. This is heights, and it follows the same patterns. And the big shift here is the shift to mangroves, and specifically big mangroves. And then on the right, this is a proportional change to do with rainfall. And it may not, this could have been plotted as a straight line, but it actually fit better with an S-shaped curve, a very subtle S-shaped curve. And you see that the difference here between sort of vegetation at 800 millimeters to that at twice that much rainfall is 4 times the difference in height, 0.2 to 0.8 or 1. And what this means is you could have a mangrove at the same temperature growing in South Texas, that'll be 2 meters, and the same temperature in Florida, and it'd be 10 meters. And that's what we see. All right, so we can then take those equations, right? So the figure at the top right here, these curves, that's the same curves we just looked at. So each curve is defined by an equation, and these are the equations. And don't worry about the math here, that's not important. But what we can do is to figure out how climate affects them together, we can combine equations for the ones that are influenced by both. So only graminoids and mangroves are influenced by both temperature and precipitation, MAP's mean annual precipitation. As succulents and unvegetated plants really are only responding to rainfall, not so much temperature. Temperature doesn't matter, but in an estuary scale, it's really rainfall that's driving their dominance. And so what we did was combine the ones for graminoids and mangroves to come up with models that predict their abundance based on both temperature and rainfall. All right, that's what we did here. We combined these equations to create these bivariate models. Bivariate just meaning that they depend on rainfall and temperature. We did some basic math. I literally used Excel to then solve those equations across this broad range of, or I should say the relevant range of temperature and precipitation, right? So any realistic range of rainfall, any realistic range of temperature, it was easy to then plug those numbers into these equations and get predictions out. How much mangrove, how much graminoid. And then I did some coding. I used R language and made some 3D heat maps and contour plots to help illustrate what these predictions are. Because just looking at that matrix of numbers doesn't help much. So that's what I'm going to show you next. And this is the result. That's this. All right. So this model on the left, these are individual models for each functional group that we then combine in panel B here. Right. So let me walk you through what this is. Right. So this is a result of that process I just tried to describe, where we created and then solved these bivariate equations for all 4 functional groups. And again, those were based on the relationships between the plants and climate that we observed in the field. So this is hard data, boots on the ground. What did we see? What does it say? And this is the model we made from it. And so basically for any temperature and rainfall values within this relevant range, so from basically -20 to +5 degrees minimum temperature, and from 500 to 2,000 millimeters of rainfall, we can predict what the likely dominance of graminoids and mangroves and succulents and unvegetated land is going to be. And it's important to note here that the predicted value is actually continuous. Like, it's a percentage, it's not just abundant or rare or yes or no, right? And so, not surprisingly, and like we already saw, we see that graminoids dominate where it's cold and wet, mangroves dominate where it's warm and wet, succulents dominate in this mid to low rainfall range, or at least become most abundant there, and unvegetated areas become more abundant and more dominant as you get into the lowest ranges of rainfall. And putting these all together, you can basically take figure B, panel B here, and pick any point. You could say, I'm going to buy a house in such and such Texas, and it's got -7 minimum temperature according to climate actuals from the last 30 years, and it gets about 950 millimeters of rainfall a year. And you can see, hey, you're smack dab in the middle of this plot. That's an area where you would expect about 1/3 of your land to be dominated by mangroves. You don't expect to see much, maybe a few graminoids. You'll have a lot of succulents and a little bit of unvegetated land, right? That's just taking it straight off this this bivariate plot. Now, once you've done all this, the next step is to then put these functional groups together. And what we have here are 6 climate zones that are distinctive of the region. Now these boxes, these rectangles, are different sizes because they are similar in climate. Right? So Louisiana, Mississippi, Alabama, and Northwest Florida, that's a really big box, but that's because the rainfall and temperature ranges for that whole region are pretty consistent. Okay, and you've got 3 different climate zones in Texas, and that's because the things change pretty significantly as you go south, right? And then you also see changes as you get into Central and South Florida. So each of these rectangles is a distinctive sort of climate zone, okay? And now that we've got this bivariate model, it's pretty easy to start to make predictions. And the same rectangles that you see in the top part can translate then, and you can stick them onto the plot we just talked about. And so these are what you would call climate envelope models. And it's really just the range of temperatures you see in these regions. And here, the rectangles refer to the range of conditions. And up here, it refers to the actual geographic area represented by those climate conditions. So anyway, so let's take South Texas, for example. It's here in the driest part. The part of South Texas we measured had about 600 to 800 millimeters of rainfall in that zone. And the minimum temperature is about 11 to about negative 11 to negative 6. That was the coldest observed in Celsius in the last 30 years. Same thing with Central Florida, Northeast Texas, whatever. And so you draw these boxes, and then you could say, okay, what's contained in this box? So it's saying South Texas. Within this box, it's areas that are mostly dominated by, you have a lot of mangroves, right? Not 70, 80%, but 20, 30% of the land might be mangroves. That's true. You see and might expect in some areas 10 or 15% succulents. That's true. You occasionally get a little bit of graminoids. That's true. And you have a lot of unvegetated land. That's true too. And the same is true for all of these envelopes. So fact check. This agrees with real life. So that's a great start, right? That always means you're off in the right direction. When your fancy model, you come back, you look at the ground and you see, does this really represent the real world? And it sure does. Indeed it does. All right. So we've done a good job of creating a model that can predict what an area is going to be like based on its temperature and rainfall. And when we look at what really exists out there, it matches nicely. All right. So this bodes well then for us being able to use this model to make predictions in the future. And that's what we did next. Okay. Once we've gone through all this trouble of making this model and drawing these climate envelopes, it's very easy to make predictions for different climate regions, right? So you can really just shift these rectangles based on what you think might happen with climate, and they anticipate future scenarios. So let's say we expect to get 2 degrees warmer and 10% less rainfall, or just 10% less freshwater availability. So you move them over 2 degrees and you move them down 10%. That's very easy and straightforward, and that's what we did here. But this has some pretty profound implications for what we're seeing, right? So we're starting to take Northeast Texas, sort of Galveston Bay. Instead of having the odd mangrove, maybe 10%, now we're in a world where you have a pretty reasonable mix of mangroves and and graminoids, right? So Galveston Bay starts to look more like Mission Aransas does right now. South Texas Central Texas, which right now is sort of the crossroads between grasses and mangroves, is starting to look more like South Texas. And South Texas is looking a lot drier. So at that point, because of that sigmoidal curve, that change in rainfall means you get a pretty rapid increase in unvegetated land. We're losing veg. That's a big deal, right? Think of those ecosystem services these plants provide. And if you're losing total plant cover, that's a loss of all that function, all that photosynthesis, all those services. Now that was this 2 degree warming scenario is, frankly, at this point, because we've been following for the last 25 years the bad scenarios, that's a pretty conservative guess. So a warming scenario more like 4 degrees is absolutely realistic. And I should say that if this is real, if we do go 4 degrees, on these climates, almost all the models agree that South Texas is going to get drier. So if we go the bad human policy route, or at least the high human emissions route, I should say, we're not just going to get warmer, we're going to get drier too. So this same pattern of shifting towards where there's veg, more mangrove dominance, and less grass. We'll pretty much lose any grass we might have. But really the key thing in South Texas is the loss of vegetation, moving towards more unvegetated land. And so we can see these patterns, we can do the same patterns with height, but that's kind of not as exciting for South Texas. Okay, so we see 2 really big patterns if we sort of step back and think about all the things we just saw. The first is a shift from grass dominance to mangrove dominance as areas warm, and we see shifts from vegetated areas to unvegetated areas as things get drier. And so what you see here is this worldwide distribution of coastal wetlands and areas that are exposed to one or the other or both of these transitions presently. You can see here in South Texas and northern Mexico, we're purple. We have this aridity gradient and this winter air temperature gradient. We're at this transition point for both how wet it is and how hot it is. And other parts of the world, the rest of the Gulf Coast is dealing with this winter gradient, this temperature gradient. The Pacific coast of California, Mexico is dealing with both, like here, all over the world. This is a worldwide phenomenon, and these transitions are a big deal worldwide. And remember, these changes from grasses to mangroves and from vegetated to unvegetated are a big deal because the types and the amounts of plants govern the types and the amounts of ecosystem services that land provide. And these coastal wetlands give us an awful lot. All right, so on that sad note, not all of my research is tragic, I promise. Current project right here, I'm going to spend the rest of my time on, and I know I've used a fair bit of my time, so I'm going to go a bit quick here, and there's not as deep of stats and no bivariate models yet for this project. What I'm working on now is concentrating on South Texas, and it's basically trying to test these models because as much as they agreed with reality, they're still models, they're still predictions, right? We want to test this empirically. We want to go out there and actually manipulate climate as much as we can and see if what we think is going to happen actually happens. And if it does, then this validates our models, it makes us trust them more, and then we can use that data to make them even better and make better predictions with them. So the big idea is we're going to catch rainfall and rainfall over temperature, because the changes that are likely to happen with temperature are pretty well established and pretty clear and a lot easier to model and guess about. It's the rainfall that is kind of a lot more uncertain. So we're focusing on rainfall, and we're trying to catch and move rain in these estuaries that are near that threshold value for the switches between functional groups. We then want to watch what happens and measure them, so we quantify those changes to plant functional groups where we're moving rainfall around. And then, of course, compare those observations to what the model predicts. And again, if we can validate that these models are correct and what we think is going to happen ends up happening, then we have more confidence and we can make these models even better. So here's the schematic I drew up a long time ago to figure out how we might realistically move rainfall in big enough places to have a community level response, and to do this on modest budget with limited manpower and time, person power I should say, and to do it without electricity so that we could do it way off the grid. And so this is what we came up with, and it's basically just some wooden boards held up by T-posts that support roofing panels. These clear roofing panels that then make an inverted roof, a V, so the water runs towards the middle, and it gets caught in gutters that are at the base of those roofing panels, and then the water in the gutters gets distributed by hoses that are connected to the gutters that then move the water back around. So that's what we had in mind, and here's what it looks like in practice. So we did this, we built this, and it's working, and it has been working. And this is what it looks like. So within this, the big experimental treatment, right? So sure, we can catch rainfall and move it around. So how do you make it some areas wetter and other areas drier? Well, you build these structures in sets. I like to call them triplets, right? And so here we see one triplet. This is from Bahia Grande, not far from the Red Gate, those of you familiar with the area. If you've driven up the main road from the Red Gate, you can see these off in the distance. There's two triplets over there. And then if you go further north, quite a bit towards the north gate, that's where you find the second set of triplets in Laguna Atascosa. So here are these structures with the panels and the gutters and the hoses, and they catch the water and then they move the water. And if that water gets dropped back on its own plot, that's what we call ambient. If you're one of the dry plots, you catch your water and then you move it over to your neighbor. So this one has about a third of its water taken away and moved over. So that makes this one drier. This one gives itself its own water, but it also gets the water from its neighbor, so it gets wetter. That's pretty straightforward, and it's not perfect, but it's pretty darn good if I do say so myself, for not having power and being done on a relatively modest budget. One of these days I'll get a bigger NSF grant and be able to spend some big bucks on this infrastructure. But as it is now, we do the best we can with the sweat of our brow and some clever, modest engineering. So that's how we're doing the treatments. We're making some areas wetter, some areas drier, and some areas we're keeping the same. And you got to have some you keep the same, because all that apparatus changes things. So you have to be able to compare apples to apples. All right. Can't seem to advance here. There we go. All right. So where are we building these things? I mentioned the ones in Laguna Atascosa. In general, we're focusing on South Texas and Central Texas, because that's where the action is, empirically speaking. That's where these cool transitions based on rainfall are actually going on, where we get into big shifts in succulents and big shifts in unvegetated areas. That's where that aridity gradient takes place, the transition from vegetated, unvegetated land. And so we picked 3 sites, and we had to do these far enough away from the coastline. We didn't put them in the high marsh, right? Areas above mean high tide. Because we could manipulate rainfall till the cows come home, but if we get tidal influence every day, it would erase our manipulation. So we did this in the high marshes where you had infrequent tidal influence. And the idea was that we'd be supplementing the fresh water that gets there, and we'd probably be doing a lot to just flush salt, which is really important. And we're doing this in high marshes in 3 places. 3 places as far as where basically the southern extent of where the high marsh is dominated by grasses, which is Aransas. It gets the most rain of the sites and it has the lowest soil salinity. Our sort of intermediate area where these high marshes are dominated by succulents is Corpus Christi and Oso Bay, where you get moderate rain and more moderate soil salinity. And then at the southern end of this, where the high marshes very often are dominated by algal mats or mudflats, is Laguna, where we get the least rain and we have some of the highest soil salinities. So here we'll cue the construction montage, and I'll go through this quickly because I'm coming up on the hour, and I do want to get to the results, even though they're not as deep as the prior experiments. So here we are loading up some equipment in Aransas, making sure we have the holes drilled before we put them on the T-post. This is Ivy Hinson, one of my grad students, making sure all our gutters are sealed nicely. Drew checking his Instagram while Ivy and Hannah take care of these panels. Drew is a superstar. He worked really hard there, so I tease him. He did well. We all looked at our phones at some point that day. Here we are after the first triplet Aransas was done. Here we are. This is in Oso Bay, the Oso Bay Wetlands Preserve in Corpus. The other one of the middle sites We also had help from Lee Smee's lab. That's Sam Ortiz, one of my former grad students, putting boards on. This is us at the coast sites at Aransas, where this is an area that gets whooping cranes sometimes. After we put these are the closest together they ever got. That's 2 sets of triplets. Here we are in Laguna Escosa. We had our campus photographer actually came out and did a story about this project. So we got the best photos I've ever had of any of my field sites taken by our professional photographer. I love him. This is one of them. Here we are carrying materials. Not me, I'm the one in the background walking back to the car to get something lighter on this picture. But I drove a lot of T-posts actually, putting these things together. Ivy putting up the boards. Jim and Drew attaching the hoses to the gutters to our downspouts. This was one of the trickier parts of this, but we worked out a system that worked well. And we're putting the panels on top. Nice long view of this array, this set of triplets in Bahia Grande. These are the plots near the Red Gate in the southern part of Bahia. We had some high school students interning in my lab over the summer a couple of years ago. They're in this picture. And I love the fact that, this is marked pride for me, is that my experiments show up on satellite imagery. So you can see my experiments on Google Earth. This isn't the first one. Some of my restoration experiments from my earlier days you can see as well. But it's very cool to be able to see that infrastructure out there. So this is Oso Bay, and this is just one of them. And to kind of just orient you where the actual sets are in Aransas, we have some close to the coast, and then some near this inland. It's still a tidally influenced lake though, but that's definitely our freshest site, is the Aransas West site. These are the sites we have in Corpus Christi and Oso Bay, near the Texas A&M Corpus Christi campus, and on their campus, and then in Oso Bay Wetlands Preserve. And then in Bahia Grande, sort of Red Gate is down here, and then these are the ones just north of there and some further north. These are the ones with the really dense algae mats. You can see that blue-green. That's the photosynthetic algae mats. You can see that in the aerial imagery. All right, so our model suggests, and I'm going to go pretty quick here, that if we're in an area that's dominated by grass and we make it wetter, we're not going to see a shift in functional group, but we'll see the grass do better. But if we get it dry enough, in theory, that should shift to dominance by succulents. So that's what we thought would happen at Aransas. At Corpus Christi, where the high marsh is dominated by succulents, if we make it wetter, we expect we start to see grasses become to dominate, or at least get more abundant. If we make it drier, we would expect to lose some succulents, maybe start to see more algae mats. And then in Laguna Madre, if we make it wetter, we might start to see succulents. If we make it drier, maybe we begin to lose algae mats. But that's the gist of it, right? And so looking at this another way, this is what we expected to see. So in Aransas, graminoids in blue, succulents in gray, unvegetated in yellow. And I should point out that I'm not focusing on mangroves here, just because they are relegated, well, several reasons. One being that they tend to be in the tidal zone. And so I wanted to stay out of the tidal zone. But one of these days we're going to do some mangrove transplants, because we expect they would behave like the grasses do. Okay, so they could be lumped in these blue bars, theoretically. All right, so in Aransas, we expect that in the ambient conditions, mostly grasses, with a few succulents and a little bit of unvegetated land. And if you get wetter, you get more grass. But really, if you get drier, you expect to see a boost in succulents, right? Realistically, we're not going to see an overwhelming shift from one to the other, just because we've got a bit more, 30% more rain. Now, that's a pretty big rainfall change, but in a realistic amount of time, and given what the soils are already like, that transition may happen, but it would take time, right? We're not changing a big enough area to really change the soils, but we expect to see this shift in that direction. In Corpus, where currently it's pretty balanced, I say it's dominated by succulents, but remember, even when succulents are kind of at their peak, they typically aren't the only thing around. You know, grasses and mangroves are typically mixed in with them pretty well. And so this is pretty much what we expect now, and what's there where we built these things. And we think if we get it wetter, we expect to see a lot more graminoids and not as many succulents. If we get drier, the opposite would happen. We'd expect to see more succulents and fewer graminoids, and also more unvegetated land. And then in Laguna, right now, some of the plots we had are mostly unvegetated, but some had a good portion of succulents. If we make them wetter, we'd expect the succulents to do better, become more dense, maybe see some grasses or mangroves, and have a reduction in unvegetated land. And if we make it drier, we'd lose those succulents, get less, more unvegetated space. Well, so we've run this experiment now for, well, we ran it for 2 years. The third year was 2020, with all that came with 2020. So we do not have 2020 data. So what I'm showing you now is through 2019, the end of 2019, which was 2 full growing seasons post manipulation. And I've got to say, what we've seen so far has been much more subtle than we were hoping. Realistically, though, the direction things are going are largely what we'd expect, not always. And I'm going to kind of finish by making a clearer picture of this. But this is early data. This is data from the first 2 years. We see in Aransas that where we've wet it, indeed we're seeing more graminoid cover and a little bit less succulent cover. Where we've made it drier, we're not really seeing much of a difference. We actually saw slightly more graminoids. We saw a little bit less in the way of succulents. You know, not really what we expected, but consistent with the general expectation patterns. In Corpus, again, where we've made it wetter, we're seeing more plants. We're not actually seeing more grasses. We are seeing more plants, but the succulents are what's mainly responded. And I didn't put error bars on here, but the punchline is that these differences are subtle, and they were very variable. And none of the differences I'm showing here were statistically significant, okay? But bear with me, because I've got some final comments about exactly that, that I'm coming up on. I'm nearly done. I know we're at 8 o'clock here, but I'm almost finished. And so we also didn't see really much of a change where we made it drier. We did see a drop in graminoids. That was something we expected. But this difference between succulents was not distinctive, not distinguishable statistically. And then in Laguna, we're not seeing much. The succulents there have been pretty sparse and have remained pretty sparse whether or not we made it wetter or drier. In fact, I take that back. I think this actually is, this one of all of these plots is the only one that had a statistically significant difference, where the dry plots in Laguna had significantly less succulent cover than wet and ambient. But in an ecological context, what is statistically significant isn't always ecologically significant, because, okay, half of 1% was significantly less than 1.5%. It's not very much change if you're a bird looking for succulents to feed on. All right, so here are some ordinations, right? So these are some pretty mathy plots. The basic idea here is that proximity means similarity. So if points or shapes are close together, they're more similar. And the farther apart they are, the more different their communities are. All right? And so the letters here are the site names. So Corpus North, plot 2, Corpus South 2, Corpus North 1. And the polygons are bounding boxes that connect the entirety of observations within an area. So we see actually quite well. So Aransas over here in this graminoid and forb-dominated world, and the names here, those are where we saw those plants, where they fit into this whole picture, right? So Aransas was mostly graminoids and forbs, and we see that the circles here are the hypothetical average community within one of these study areas. And we see that, so this part of Aransas, this gray one, that's your average Aransas site. This red ellipse, that's your average Corpus Christi site. This very narrow green ellipse over here is your average Laguna Atascosa site. And so they actually separate out pretty nicely, not surprisingly. And what we see here, we can break it down into, this is sort of generally what we saw at the start, and this is what we're seeing now, right? So this is after we've done these treatments. And we're starting to see some separation, right? But they're still in the same worlds, right? We're not, if our predictions hold, we would expect Corpus wet to be overlapping with Aransas dry, and that's not really happening yet. We would expect maybe Corpus dry to begin to approach Laguna wet, and again, that's not happening yet. So maybe 2 years is not a lot of time for a climate change experiment. This is we only had funding for 2 years, and we're holding it together as best we can. COVID did not do us any favors for keeping things going well when we had to keep it together with sweat and duct tape. But 2 years is just the beginning. It really is. Really, really is. So none of those differences I showed you now, with the exception being that Laguna Atascosa succulent one, none of those were statistically significant. But null results are still results, right? Maybe these changes in rainfall are really not going to make that profound of an impact on plant communities. Maybe there's something else that's really driving the factor. We don't necessarily think that's true. That's not what our models say. But null results matter. They're still results. And it could, again, just be that these changes after 2 years have been too subtle to detect. You know, there's just every replicate here is a whole lot of money, a whole lot of hour, a whole lot of toil in the mud and sun to build another rainout shelter. So with as many samples as we have, as many observational units as we have, we need to have a pretty big pattern to be able to detect it. But we do see the patterns we were expecting, right? They're subtle. They're smaller than we had hoped at this point, but we are seeing nuances. We're seeing the subtleties of what we're expecting to see. So, and I got to say, in terms of gains or losses in specific functional groups, we are seeing those, but it's not always as expected, right? So, for example, in some cases, we saw smaller losses than we expected to. We saw smaller losses in something when we were expecting to see a gain. So what that might mean is, in the last year, the last 2 years, it was dry, and these things would naturally have gone down. But because we were making it wet, it went down less than the other plots. So this is still in this background of all the natural variation still happening out in this habitat. So that's where we are now, is we're taking a much more careful and intensive look at these smaller, subtle, specific directional changes. And I think that's where we're really going to see some important statistics, all right? So there was also a lot more variation among the shelters than we expected. That's life, that's ecology, it's a dirty world out there. And also very, very important for the statistical findings is that all the data I showed you now in this plot were based on our visual estimates of coverage, right? So we go out there, we stand there and we look, me, as an old hand in doing this, you know, this plot has 45% grass cover and 15% succulent cover. What we're doing now is with those visual estimates, we also took systematic high-resolution photographs of all of these plots. And we're using those now to create much more refined estimates. I shouldn't even say estimates, of actual analyses of the total area, right? So I was estimating coverage in subplots. We took photographs of the entire area under these shelters. And so this is going to not only increase our number of observations, it's going to increase the amount of space that we're analyzing, and we're going to be able to do it with more precision than a visual estimate. So my hope is that when we combine, and I'm cautiously optimistic that this is going to be the case, when we combine this photographic analysis with careful examination of the shifts we're seeing, especially in light of what climate patterns have been, we're going to see some significant differences between these plots, even now at sort of year 3. And of course, hopefully, we'll find the capacity to keep this going, and we're going to run it for another 4, 5, 6, 10, 20 years, and we'll have some really profound changes after that time. So that's it. Thank you very much for listening. I'm sorry I went a little bit over. This was a big project from the start, where we were bringing in surveying across the Gulf of Mexico, to the team more recently where we're analyzing, where we're manipulating rainfall and testing these models empirically. Everybody in my lab, collaborators from Texas A&M Corpus Christi and Dauphin Island, USGS, University of Houston, and of course Sea Grant was our primary sponsor. We got the main grant that supported this work was from the Texas Sea Grant program, and we've got support in kind and with support from all these universities and institutions as well. So thank you all very much for listening. I'm happy to answer questions. I love working with Texas Master Naturalists. 2 of my students are Texas Master Naturalists. If any of you know Sam Ortiz or Jennifer Baez, Jenny's a current grad student. Sam was my first grad student. I'm happy to talk science, consult about anything related to restoration of invasive species, answer questions about climate change, you name it. Thanks very much.
Dr. Gabriel, this is Tony Reisinger. Thank you very much for acknowledging Sea Grant. And I'd like to ask you about the recent freeze that we had. It looks like it knocked down quite a few of our black mangroves. What impact do you see in the future of production from them? And it looks like we're going into a drought.
Yeah. Excellent question. I'm getting asked about the freeze a lot, including about areas that are not really my area of expertise, including renewable power. Some of you might see me on the news answering questions about that. I do know a lot about renewable energy, but I'm much more qualified to answer questions about these mangroves. So they absolutely got hit hard. I've been, if I didn't have 3 grad students graduating this semester and 3 young children, I'd be out there measuring mortality and figuring out the extent of dieback on these mangroves today, right? That's a really big deal. We have seen it before, right? So in 1989, we had a really big dieback of mangroves, and one of my postdoc advisors, Mike Oslin with the USGS, did a lot of work looking at that then at sort of like a geographic level. And so we've seen them recover. Exactly how much they've gotten knocked back, this invasion front, and I use invasion, it's a natural invasion, apart from the fact that humans are influencing the climate. But in terms of, this isn't invasive species in the sense that we move the species around artificially on purpose or accidentally or whatever. This is a natural poleward migration as climate changes. And so there's that population front that's been moving poleward, moving north for the last 30 years. It's undoubtedly going to get knocked back. How much, I don't know. Time will tell. We've seen some really interesting patterns for what gets knocked back and when. For example, we've seen that once mangroves get dense enough, they tend to create this sort of population level protection where the outer mangroves buffer wind and wind chill and shear. And so the odd mangrove, and if you go and you look and you see the tall mangrove, it's frozen off. It was sticking its neck out, and that's lost. But all the stuff that was about the same height, sometimes it survives, right? And it really depends on exactly what the patterns were in certain areas. And microclimatic patterns are going to mean some patches stick around, others don't. Having a bigger, denser patch might mean the interior trees survive and the ones around the edges don't. That's a tremendous thing to be studying right now, and I'm eager to get out there and look at it because I'm trying to find that out myself. But it's going to get knocked back. We don't know how much, and to go from freeze stress into drought stress, whew, I mean that's the name of this game, right? That's one of the core points of this talk is that availability of fresh water is a powerful deterministic factor in what we're seeing here. So that's a pretty intense 1-2 punch. I would not be surprised if we see pretty significant reductions in our mangrove cover. And I'd be really curious to see, and I'm going to have to go poke around more further up the Texas coast to see where things look in terms of where populations are still intact. Great question. I wish I could tell you in more detail.
Hopefully Sea Grant will give you some emergency funds to study that.
Hey, I didn't think about it, but I mean, like NSF has the I can't remember what the SER program. I mean, this is a golden opportunity to look at what that freeze impact has had, and to then track it as we go into possibly drought scenarios. This is a good time to have rainout shelters around. But yeah, I'm going to look into that because that'd be a good proposal, I got to say.
Great talk. Thank you.
Thank you very much. Excellent question.
Does anyone have any other question? You may unmute yourself and ask.
I'm excited I got one. You haven't gone so far over. Thank you, Diana. I often get told, when my students are like, "Wow, Dr. Gabler, you're really into this." Of course I am. Why aren't all your other professors? It's palpable. I'm a passionate dude about this, and that's it's suited me well. It really helps me connect with my students, and I'm glad you noticed. Thank you. I love what I do.
Well, this is Barbara. It definitely shows that you love what you do, and you so relatable to us. And thank you so much for your time tonight, because this was a great presentation.
Thank you, Mo. Absolute pleasure. I really do love. I mean, I like to be able to give talks. I really like to give talks that aren't technical, not so technical. I gave you a lot of p-values. That was a pretty technical talk, but when I don't have to be strict format, I can get into the broader implications a lot more, and that's really why I'm doing it. I mean, these affect this sort of change affects so many people in so many ways. I really appreciate the opportunity, the soapbox, to tell you guys what I'm seeing.
Well, thank you so much. We definitely look forward to hearing from you in a year or two when you go back and take a look at what else the data is showing you. I think
Absolutely.
We're definitely all living here, and we're very much interested in what's happening around us. So definitely keep us in mind, and you'll.
I look forward to part 2, the return.
Excellent.
Now with more data in a year or 2 or 10. I'll be around.
Fantastic.
I hope. So.
Absolutely.
All right. Again, thank you, Dr. Gabler.
My pleasure. I'm going to go make sure my children are fed and get into bed. So
Okay. Have a good evening.
If anyone has any other questions, by all means, shoot me an email, give me a call. Love to hear from you. Thank you again.
All right. Let me just get a confirmation from someone that you do see our presentation again.
Got it.
We do.
All right. Very good.
I'm in.
We're at 8:18. We've got a few minutes left. A couple of extra things we wanted to share. Again, some of the speakers that we have in the works, Jason Ferguson with the fishery stations. I do need to confirm these individuals, but this is sort of our plan as it is now. If you do think of anyone that we should consider for our chapter meetings, certainly feel free to let us know. I wanted to share a couple of things that we've done from communications and outreach. Many of you should have seen that we have published the latest version of the Chachalaca. Please check it out. You can find it on our posted on our Facebook page. It's also on our website, and we have some really talented members with artwork that they allowed us to publish. These are really impressive work and great stories from all the contributors. So definitely go check that out. Last week, it seems like forever that we've done some sort of outreach. We had an opportunity with the Texas Plastic Pollution Symposium. We had a lot of our members go out there and volunteer. It was great to be out there with the public. It was great to sort of share what we do, and definitely, we appreciate everybody that went out there and chipped in. It was a great event. I think, Barbara, where was the next one going to take place? Galveston?
Port Aransas, I believe.
Okay. Maybe we can make a trek out there and help Chase with his symposiums. These were really interesting. But again, it was just great to be out there and have our table back out at an event that we can share what we do. We have published the March Advanced Training Opportunities list. I quickly glanced at it, and we have about 23 opportunities, which is about 28 hours worth of additional AT credit that's available. We do have some volunteer opportunities that are ongoing, including some of the ones that we are very familiar with between Ramsey, the Birding Nature Center, Sea Turtle. The Native Plant Center is trying to revamp their volunteer team. We're working with ACUS on the Hummingbird Brigade. City Nature Challenge is coming up. The Monarch Watch, if you saw one of my posts on Facebook, there was a report that the monarchs are starting to do their migration, and we can contribute to that citizen science project of monitoring their presence. If you see some in your yard in the park that you like to walk along, there's a place for you to be able to log those observations. Some of you have already volunteered for the Texas Butterfly Monitoring Program. If anybody wishes to do so and hasn't, just let me know. Again, the Adopt-A-Loop is something that we're working on, and the Manfreda Conservation effort, I know that we've submitted our names and we're waiting for the Butterfly Center to schedule the training on that. If there is any kind of opportunity that is missing that you wish we had, let me know as well. We need to figure out what are some of the things that we're not doing that you wish we were, and we can find a way that we can fit them into our program. We are looking at some other opportunities that were presented in the virtual volunteer fair. The first one that we have listed there is just from us working with the Coastal Fisheries Station and our desire to put some trails out there. But there's a meeting later this month on the Adopt a Paddling Trail. I haven't heard much from the Invasive Species Survey. The Plant ID Bingo, I really like. It's really cool, and hopefully I can share a little bit more information after their meeting. I think it's next week. And we are helping with the Shell Club. They're bringing their meetings virtual, which hopefully they might have one even this month, which is fantastic. And that's always an AT opportunity for our chapter to attend their meeting. So hopefully we'll hear from them soon.
What is the Shell Club?
What is the Shell Club? Was that?
Yeah.
Is Frank online? Would you like to respond, or Linda? They may not be online, but they're basically a group. Sort of the way my understanding is that they have a fondness and fascination for shells, especially some of the ones that they find just by walking along the beach. They do several presentations about them. Oh, Cecilia, I think I saw you online. Are you there?
I'm here.
Oh, Linda, would you like to share a little bit about the Shell Club?
Well, previously we've had at our meetings, someone will give a presentation sometimes on a particular shell that could be found on our beaches. I'm going to be doing a program on sea beans. I believe it's in April. We're just really getting started back because of COVID. We didn't have any meetings last year, and we're going to try, I believe, next Wednesday. And Linda McGonigal, if you're still on here, you can correct me if I'm wrong. I believe it's next Wednesday. I don't have a calendar here in front of me. Frank is going to give a history of Shell Club, and it's been going on for a long time. But mainly our meetings, we will discuss a particular shell or a particular sea bean or just anything really that's going on the beach.
That sounds really cool. I'm excited to, if there's AT stuff coming up, I'm excited about that.
Our meetings normally are just from, I think, October through April, but with if we can get this virtual thing going, we're going to try to go ahead and have meetings throughout the year. A lot of our members are winter Texans, so they'll be able to participate even though they're not here.
The dues are inexpensive, right, Lynn?
I'm sorry, what?
The dues are very inexpensive.
Yes, they are, and I'm not sure exactly what they are, but I think they're less than $10. Linda, are you still on here?
Yes, yes, the dues are $10, and that's probably the cheapest fee you'll find for any organization for what you get out of it. And like Linda said, we've had all kinds of topics related to the beach. We've had sea worms, we've had beach erosion, we've had commercial shell usage. There's just a myriad of topics that we've had over the years. The Shell Club started in the 60s, and Frank's mother was one of the original members.
I'll be giving a history. My camera is not set much.
We can. Linda did an interesting program, I guess it's been several years ago now, on sea stars. Barbara and Adrian did a program on horseshoe crabs that was really interesting. So we just have really different, anything that has to do with the beach or washes up on the beach, there could be a program on it.
And we'll definitely share more information about their meetings for all of us to be able to join if we can. Thank you, Linda.
Yes.
Again, if anybody has any ideas, any questions, if you have suggestions on speakers or programs or volunteer opportunities, drop me a line, let me know. We can definitely go out and research and see if there's something that we can fit into our schedule. And our next meeting will be on April 13th. So keep an eye out, put that on your calendar, same time. Does anybody have anything to share? Or any comments or questions? We've got 2 minutes left.
Great photos, Robert. Who took those?
I did.
I mean,
we happen to have a really good year that one time in our backyard. We're hoping again that they'll stop by to visit.
Beautiful. Beautiful.
There's a question in the chat about Willacy County and Port Mansfield. Opportunities in Willacy County and Port Mansfield.
Some of the things that we do have that might fit into that are things like the adopt a loop. There are loops that extend out in that direction. The Texas Butterfly Monitoring Program, for example, are things that you can choose where you're going to, your route to watch for butterflies. So there are things like that that are possible. If you want to drop me a line real quick, I can definitely share a little bit more about some of those things that are not bound by a location. And I think that might be things that can help. And at the same time, if there's anything that you know of that is happening in Willacy or around Port Mansfield, let me know. Again, Adopt a Loop, that I'm trying to think of the name of that street that heads out there towards Port Mansfield, is a site on the Adopt a Loop, and so we're interested in being able to capture the wildlife that's there and log it on iNaturalist on their Adopt a Loop project. Same thing with Port Mansfield. There's a specific sites at Port Mansfield that we want to go out there and log the wildlife that's there. So again, just shoot me a quick.
I think that the park that's in Port Mansfield, it's called like Family Nature Trail or something like that. That's on one of the loops, the Adopt the Loop loops.
And so's the end of the road that's currently being under construction. I think they're renovating the boardwalk, and so that one we may not do right away until they finish that construction. So there are definitely sites there that we can ask for help. And that park, not only could you do the Adopt a Loop, logging the wildlife that you see there, but that could also be your Texas Butterfly Monitoring Trail. So that location could fit both projects. And so again, I can help share some of that information if you just want to drop me a line.
Also, Master Naturalists have helped with the Port Mansfield fishing tournament over the years. They didn't have it last year. Alicia's worked.
And I also know East Foundation, we have a volunteer that helps them sometimes with their classroom training, outside classroom training.
Tony, when is the fishing tournament out there?
It's usually at the end of July, but I haven't heard anything for this year yet. So hopefully it'll happen again.
There may also be an opportunity to participate in Wild in Willacy. I forget what time of year it is, and so I don't know if, the opportunity was missed because of COVID, but whenever we get through this and they have their Wild in Willacy event, there's probably an opportunity there.
I think that takes place sometime around October.
And definitely, as any one of us is aware of some event that we can participate in, of an opportunity that we can volunteer at, or an AT opportunity for us, just let me know, or let any one of the officers or anyone on the leadership team know as well.
Robert, if anybody is interested in Shell Club, they can send me an email. Just look at our membership list, and my email's on there, and they can send me an email if they're interested in joining or just want some information.
Excellent. I'll also post it on Facebook and send it out to the listserv just in case anybody doesn't have the membership list.
Okay.
Thank you, Linda.
You're welcome.
All right, everybody. Thank you guys for spending an hour and a half or so tonight, and hope you have a good rest of the evening, and we'll see you on April 13th.
Thank you, Robert. Great job.
Bye, everybody.
Bye, everybody. Have a good week.
Bye.